energy efficiency matters a lot in the data centers. Now, let me just give you a quick brief about the data centers. It's nothing but a centralized facilities housing the computer, server, storage, and the network equipment, which supports this cloud computing, e-commerce, and social media and the online services. This kind of infrastructure required very reliable, efficient, and the scalable solutions. Now, what are the cooling challenges, major cooling challenges in the data centers? The servers in every data centers basically produces this intense heat, reducing the component's lifespan. So the heat generation is one of the major challenges in the cooling sectors. High density, increased server density exacerbates the heating issue. And most important, in cooling accounts for close to 30 to 50% of the data center's energy uses. So energy consumption, cooling energy consumption is one of the major factors in the data center application. Finally, the reliability. Any cooling failures will increase the downtime in the data centers, which can be a catastrophic failure for any of the data centers. Now, what are the industry trends today? Now, most of the data center players or data center customers, they are basically focusing on increased focus on the energy efficiency. They are basically concentrating more on the modern technologies, starting with the free cooling. There is a growing demand of the liquid cooling and hybrid cooling solutions. Now, there are a few key statistics, based on which data center players are playing a great role, and they are pushing all these data center manufacturers or suppliers to really concentrate on energy efficient solution. There is a data stating that data center consumes close to 1 to 1.5% of the global electricity. And out of that, cooling accounts for 30 to 50% of the data center energy uses. And average data centers, which has been told that this power uses effectiveness is close to around 1.67. Now, data centers, there is an expectation is that data centers energy consumptions from the cooling side is expected to be doubled by the year of 2025 or probably in the upcoming years. That depends on the kind of the aggressive plans all these data centers players are having. Why energy efficiency matters? Energy efficiency matters both in terms of efficiency and the sustainability point of view. Data center contributes 0.3% of the global carbon dioxide emission. Energy efficiency basically reduces the operational expenses. Efficient cooling enables higher server density. Energy efficiency system reduces downtime risk, and finally, efficient infrastructure support the data center growth. Next. These are the typical DC cooling solutions available today for, for data center application. I'm not going to discuss much about it. My co-speakers are going to talk more about this. I'll just basically just task bait about these solutions available. One is that air cooling solution, another is the liquid cooling solution. In air cooling solution, we have a type like DX cooling, chilled water cooling, and then HV cooling solutions. And the liquid cooling solution is something is basically for the high density application. And these users of all these applications depends on the type of the data centers and this, the kind of infra kind of, investment that every data center players are looking for. Next. So these are the basically products that Trane Technologies can offer in the data center space in both in the in-DC room and the out-DC rooms. Will not talk much about it. You say that there are products available in the direct expansion cooling solution. There are products available in the chilled water cooling solutions. Similarly, for the HUs and the liquid cooling solutions. Vivek, next. Now, this is the today's subject for me, and which I would like to spend a little more time about, this free cooling. What is free cooling? With the ever-growing appetite of data management needs to be handled with care. One also needs to focus on amount of carbon footprints that data centers are leaving behind. To ensure that data management systems are managed efficiently, we must understand that how free cooling in data center works. Like everything, we as a human beings, our expectation is that everything should be available at free of cost for us. So if this is the expectation, then why pay for the normal compressor-based cooling when you can protect your servers from heating for free? So in today's discussion, I'm going to discuss basically the challenges of running of a data centers and how with the help of free cooling, we can have a sustainable solutions for futures. By name itself, we can make it out. What is free cooling? It's simple. It is like using a colder ambient air to perform cooling rather than the refrigeration cycle of the chiller. In our HVAC system, okay, or technology or terminology, we call this as a water side economizing system or yard side economizing system. I'm sure many of us are well known about the yard side economizing system, and I'm not going to discuss much about it. Today, I'll be concentrating mainly on the water side economizing system. Before I'm getting into the water side economizing, let me just touch base about the yard side economizer process system. And yard side economizer is typically used for a package rooftop or tied to an indoor air handling systems, allowing filtered outside air into the space when outdoor temperature drop below the indoors room temperature, thus eliminating the need for refrigeration cycle to be running. Indoor space is being cooled, yet the refrigeration system is not running. Hence, the name is called free cooling. Now, if we transition back to the chiller world, the equivalent would be free way to supply whatever the temperature chilled water we need without running the chiller. And that's something is called water side economizer. In terms of chiller, is called a free cooling. So free cooling isn't literally be free because it does require a lot of capital investment to own, but payback period can be much rapid depending upon the range of the ambient temperature. It means, okay, depending on the climatic conditions that, okay, you are selecting those chillers and depending on the application and the chilled water living temperature. For an example, free cooling may not be applicable anywhere and everywhere. If you talk about the healthcare segment, if you talk about this pharmaceutical segment, where your process chilled water requirement comes close to 4 to 5 degrees centigrade, their free cooling payback period would be really very, very high. So free cooling may not be applicable in those cases. But if you talk about the DC space, where servers, today's modern servers are able to take and withstand a very high temperature. So chillers can be designed at a very high elevated living water temperature, and payback period in such applications could be even less than a year. Now question comes that, can we combine a free cooling with the chiller unit into one? Answer would be that yes, we can definitely combine a free cooling and the chiller into one, and that's commonly referred as a hybrid chiller. And what is hybrid chiller? A hybrid chiller is a cooling system that incorporates both a chiller and the free cooling system in a single package. The system is designed to take advantage of the free cooling potential of the ambient air when the outdoor temperature is low enough to provide sufficient cooling, and to switch to mechanical cooling when the outdoor temperature rises. And that is happening through this modulating valve, through a modulating valve, to a modulating valve, depending on the manufacturer to manufacturer. Now, I have just typically made one bar chart, which shows that free cooling hours for a very typical city in India. Why it is so important? Before selecting a chiller or a product, okay, which has been designed or selected for water side economizing system, we have to make sure that this sufficient free cooling hours are available in that particular conditions. That means climatic condition has to be very favorable in order to get the maximum output from the chillers. Now, this typical bar chart shows that at 35-degree dry bulb temperatures, out of 8,600 hours in a year, we can almost encash 6,500 hours for the free cooling. And that's the perfect example or area climatic condition for free cooling application. Now, there are many types of free coolings, okay, which can be incorporated in the chiller. Their modes are basically mechanical mode, hybrid cooling mode, and free cooling mode. Now, let me give an example. This is a very typical schematic how free cooling chillers are being designed. Okay, now just give me an example. Let me just show you an example, or taking through an example. Just as I assume there is a typical data centers. We are designing a refrigeration systems or air conditioning product or HVAC system, where data centers requires around 27-degree chilled water living temperature. Now, for this effective water use effectiveness, okay, we can always decide a data center at 10-degree delta T. And if we design chilled water living at 27 and return water temperature of 37, how this free cooling affects in the chillers? Let's explain and understand from this circuit. Now, return water coming from the load, that is from the server, if the ambient temperature is more than the 37 degrees centigrade, basically it will directly go to the evaporator. It will never enter into the free cooling circuits. So there will be a mechanical cooling circuit will be activated and compressor will be fully throttled to perform and make sure that okay, desired chilled water set temperature is met. But what happens in a hybrid cooling solution, which is very important for most of the climatic conditions of our country, because we don't live in a very cold climatic conditions like most of the European countries and some part of the North American countries, where you have a very flexibility is there in the ambient condition in order to operate these free cooling chillers. But in hybrid cooling is very much applicable in our case, and all the modern chillers are incorporated with like mechanical cooling sandwiched with the free cooling circuits, where you can encash the benefit of hybrid cooling advantages. Now, in case of hybrid cooling, again the same, the chilled water which is coming from 37 degree from the load, it will, instead of going directly to the evaporator, it will first enter into the free cooling circuit. And a free cooling circuit will ensure that heat transfer happens efficiently, because outdoor air temperature is lower than the free cooling circuit. And the outdoor and then evaporator entering temperature, instead of 37 degree, it may be 36 or 36.5. So what happens if the entering water temperature drops down? It basically reduces the workload on the compressor, and thus it is gaining the efficiency from the chiller. Now, when the compressor is working less, obvious reason is that the chiller is more efficient. Typically, what we have observed that any air cooled chillers, okay, which has been designed for a free cooling system, if it typically runs on the mechanical cooling mode, we have seen that integrated average coefficient of performance of the chillers comes close to around 6 to 0.62 kilowatt per ton. But whereas if we integrate the free cooling circuit and if we take an advantage of hybrid free cooling mode, we have seen that there is a gaining in the efficiency or cooling load factor improvement from this HVAC equipment comes close to around 30 to 35%, which basically contributes overall PU of the data center close to around 70 to 80%. Now, there are some climatic conditions, okay, where we can gain 100% free cooling. In that case, ambient temperature or climatic condition has to be so much favorable that you don't need to switch on the compressor at all. In that case, only condenser fans will be running and ensuring that okay, your building load has been met and chilled water temperature has been met. So this is briefly about just free cooling circuit and the chillers, how it works on the chillers, and free cooling circuits are efficient.